So the break is over. We still have 2 hours left before the standard workday ends. So let's make it. So we have finished with the description of the different layers. The fast RTPS is the default one. I hope I'm still recording. Yep. The default one, which you use even if you don't know about it. But in all the examples that comes with the ROS2 version of our system, you are going to be using Xeno. Switching between these layers is relatively easy, with some caveats. If you want to switch from the default to anything else, you need to export an environment variable. That's it. If the layer is installed, and it's going to be installed as a part of the MRS system, then doing export RMV implementation equals to RMV underscore, then insert your favorite layer underscore CPP. Doing this and making sure it's exported or it's set in the terminal where you run your stuff will do the thing. So if I want to run a node using Xeno, I would just export RMV underscore Xeno underscore CPP as RMV implementation variable. If I want to run fast RTPS, I'm going to do this. If I want to run Cyclone, the right term is Cyclone DDS. And that's it. Obviously, if you run Xeno, this is not enough. You then need to run the core, the router, which will make sure the nodes have someone to communicate with. So if I'm going to export RMV Xeno CPP, I have nothing else running. I'm going to do ROS2 launch. Yeah, you're going to need to unlearn your ROS launch and learn ROS2 launch. It takes a few months. Yeah.
Can we have show addition for that?
We could, but I think this is a good thing to learn natively. So I just bit it, and I relearned it. And now my ROS1 habits are gone. Because then you have ROS2 echo, ROS2 topic echo, ROS2 service call, everything in ROS2. So I'm okay with transitioning. I don't need to have the old stuff everywhere. So ROS2 launch, I don't know, MRS, UAV, auto start. I'm gonna run. First one, yeah. This. So right now, my node is objecting that it's unable to connect to Xeno because I'm not running the Xeno core, the router, and it's even like run it. So if you don't know anything and you want to run Xeno, you are just gonna copy this, which is ROS2 run RMV Xeno CPP, RMV Xeno D, which is like Xeno daemon. So I'm gonna just paste it here, and suddenly the node in the top should come to a live state, and now it's waiting for data because I'm not running anything else. So the fundamental basic switching of the layers is simple. You just export the right variable. So in the Tmax sessions, which we have prepared for the simulation, it's one export in the header part where it's exported for all the terminals, and it's done. Then you need to run the core. Then there are caveats. Caveat number one. If you want to switch from layer to layer, from Xeno to fast RTPS, sometimes it makes sense to do stuff with fast RTPS if you are lazy and don't want to run your routers. If you want to switch and you want to have your terminal know about the layer, so your ROS topic list, so ROS node list, ROS topic echo, these are ROS nodes as well, and they need to know about the layer. You have to have the right export in your bash RC. For ROS topic list to know that it's supposed to find the nodes through Xeno or fast RTPS. By the way, you could have two ecosystems running in parallel, each using different communication layer. That's nothing wrong. You could do it. And now there are even bridges between these layers. So you could have one part running fast RTPS being bridged to Xeno. There are situations where it's it might be beneficial. So if you want to actually switch from one to another in your terminal, you are obviously gonna export it in your bash RC or DHRC. So in my case, I have a small section here where I export the RMV implementation. And if you change this, the problem is it's not gonna change immediately. So right now I'm running Xeno. If I comment this and uncomment my fast RTPS, which is basically the default, so commenting everything is like uncommenting fast RTPS. If I just open new terminal, it will still run using Xeno, even though I have exported the new variable, because in the background, there is some daemon running for all the terminals. It's somehow centralized. And your new terminal will still be running the old RMV. You can Google how to solve it. It's good to know that the problem is even there. You need to kill the daemon, make sure it's dead. So I have a pkill-9-fros and ROS2 daemon stop. You need to run this to actually effectively switch the RMVs. So I run this, I close all my old terminals, I run it again just to be sure. And now every new terminal I open should actually use the new RMV that I set. So right now, if I do ROS2 launch, I don't know, MRS, UAV auto start, automatic start, it's just gonna start because it's using the fast RTPS, no core. If I just switch to Xeno and do nothing, open new terminal and start this, okay, magically now it waits for the core. So maybe there are some edge cases to the edge cases. But anyway, if it doesn't work for you, just ROS2 daemon stop and pkill everything that has ROS in it, and it will make it work. So that's switching. And that's OK for simulation. You don't need to do anything else for simulating. The default settings for the router are just fine. The problem appears when we want to connect to a real drone. For connecting to a real drone, we are living in the completely centralized and opt-in world with Xeno. You need to actually configure a laptop to see the drone. So when you run our example session on the drone will live very happily, but to actually see the topics from the drone, you need to run the router on your drone with settings that will tell the router to actually check for the drone's router, such that the routers can communicate with each other. This is done with a config file, which the default config file for that you can quite easily find in ROS2 Jazzy share Xeno CPP something. Somewhere there is a file somewhere hidden. Oh, I totally forgot where it is. Somewhere in our system, there is a live version of the default file which configures Xeno. Where are you? Xeno RMV, Xeno CPP, the same package which you use to run the router. There is a config, and there are two files. Which one is called config for router, and the other one is called config for session. The config for router configures the router itself, the core. The config for session configures the nodes. And this can tell the nodes to either connect to the router or not connect to the router at all and do the scouting on their own. We typically don't modify the session config, and we only modify the router config. And the modification is done by copying this file somewhere else, modifying the sections that we need to modify. And by the way, this works in the same way as our custom config mechanism. So you can only take part of the file that you want to modify, and you can keep them in. It's a JSON file, so it's quite easy to dig them out. And then, if you have this file and you place it somewhere in a laptop, In my case, I have like a folder in my home, which I call ROS2 deployment. And in here, I have a folder called Zenoh with a file called Zenoh router. And in here, I have a section which tells my router to connect to specific host names, depending on what I do. So whenever we fly with a different drone, I'm just going to add this, plug the drone in, and it's going to be connecting to the drone. You can have multiple drones in there. It's quite simple. So right now, there is no one-to-one relation like with the old ROS master URI. There is end-to-end. N routers can be connected to N other routers, and it's super powerful. So the way is to change this file, modify this list of endpoints. So there's a section called connect endpoints, and you specify the host names or the IP addresses. And then you export another variable, which is called Zenoh _router _config _URI. Give it the address to the file, and it will overload the settings that you changed over the settings that are in the default. So these two variables is what configure the Zenoh, and in the file you are configuring to which drone you're going to connect. Now the important bit: we have a sample of this file, which you should use to start with. You are going to find this in the installed package called MRS UAV deployment. So that's the package that typically hosts the stuff that is specific to deployment of real robots. It has the example Tmax session for a real robot. It has the config files for the drones, everything that is specific to hardware. And there is a folder called config/Zenoh/UAV router. Use this as the starting point for configuring your own laptop, because there are some other stuff that we have changed that make sure large data like point clouds and images are happily transmitted between your laptop and the drone. So if you are seeing stuff in RBIS, like point clouds, without this config, it might happen that the point clouds might not be getting through at the proper rate. So the right mechanism is go into MRS UAV deployment, copy this file, place it somewhere in your home, modify it. So here are the endpoints. So add your own endpoint, something like UAV 30 or 129, 168, 11, or what is 69, 120, whatever, and set the environment variable, which is Zenoh router config URI, and this will make the router use this config automatically. And then when you start your drone and you run your RBIS, you are going to see the topics. Or when you run ROS topic list, you are going to see the topics. Then what's great with ROS2 is it's still decentralized. Even though we are running a core for Zenoh, it's just a central point for the communication layer, but the ROS2 actually doesn't know anything about the core nature of this. ROS2 is fully decentralized. So if you run RBIS on your laptop and you have your drone running, these two are sort of independent. And if you stop the drone, start it again, you don't need to kill the RBIS to connect it to the drone again, like you needed to do with ROS1. Because now it's decentralized and distributed, and it's supposed to run sort of arbitrarily in parallel. So you can have one RBIS running for the whole afternoon. You don't need to stop it and start it as your drones are being killed and start it again. So this is actually quite a quality of life improvement, and it's great. By the way, with Zenoh, we have had some pretty good experience. We have had a drone running in the lab, connected to an internet through Tailscale. I was connected to the drone, and I set up my Zenoh endpoint to the Tailscale endpoint of the drone, and I was seeing images in point clouds real time over the internet. Zenoh is like quite great for this. What's good is that right now we don't know about any particular problem. So it works, it flies real time, fast. high bandwidth, low latency, and unless you actually configure your routers to see each other, you're not gonna see topics from another drones of your colleague researchers just on their own. So we are not gonna go into each other's garden. Yeah, I think right now this is the way to go. Maybe later we are gonna find out that this is also the way to go. Right now, I think fast RTPS is not the way to go because it really causes runtime issues. One of the other runtime issues, sometimes when you call a service with this, the service client just freezes and it never responds, and you don't know what happened. Yeah. Like maybe I'm doing it wrong, maybe we are specifying the quality of service poorly, but like to actually know how to do it right, you would have to spend a lot of time fiddling with the stuff, and it's just not worth it. Xeno totally fixes the issue. Yeah, so you need to learn new stuff, but as a bonus, you can totally ditch the old Nimbro setup. There's no Nimbro needed because you can communicate end-to-end, and drones can see each other. There are even ways how you can somehow tell Xeno to throttle data on certain topics. I haven't used it, but the options are there. So the stuff that we had with Nimbro, which is throttling and basically limiting what topics are shared, it's probably possible. I would love if any of you do multi-robot stuff would investigate how Xeno is configurable in this way. I haven't done it myself, but like if I show you all the stuff that you can configure with Xeno, where is it? Xeno config, like the amount of stuff, and it's by the way well documented. The amount of stuff you can configure with Xeno is like a lot, and it can do amazing things. So please, for multi-robot systems, please investigate yourself how it can be like tuned and set up. I think there are some message filters, QoS filters, whatever filters. So please.
When we are to simulate multi-robot scenario, is there some nice way how to simulate multiple Xeno cores? I think it might be quite easy that you can tell one node to connect to one core and you have several cores.
Good question. I have not thought about running multiple Xeno routers. You probably can. But I might think you might need a different network interface for each of them. I don't know. I believe this would be a matter of configuration, but I would rather separate the drones by the ROS domain ID and have them run through single Xeno than to have multiple Xenocs. You can isolate them through the domain ID quite easily. But good point. I haven't thought about this. Yeah. So please, people who do multi-robot stuff, investigate yourself how to configure this properly for emulating what the Nimbro could do. I think it can do it on its own. Just the throttling is the part that I haven't investigated. But with Nimbro, you had to explicitly share, like list topics you want to share. Now everything is shared. You just subscribe, whatever you want. So that's Xeno, that's RMV, ROS middleware. Yeah, there's one thing. If you installed ROS2 system, ROS2 MR system, something like a half year ago, or I mean in the past, there might be a slight chance you have an outdated version of the Xeno package, because there was a time where there was a bug. We fixed the bug by compiling a different version ourselves. We had it on our PPA, and then we don't have it on our PPA anymore. And it could happen that you have a wrong version of the Xeno runtime. So if it's the case that you are one of these who installed MRCAV system in the past, just do upcache policy ROS Jazzy RMV Xeno CPP. And make sure that the version that you have installed is something like 0.29 or newer, and it's installed from the official ROS repositories. If you have some older version that is installed from our own one, it's wrong. Please don't use it. Uninstall it manually. Do sudo apt update, sudo apt upgrade, and install the official one, because the older version could break stuff for it. So make sure you have an up-to-date version. But if you install the system right now, you are going to get the official version. So any questions regarding the communication layers? Everyone is up to date? Awesome. This is kind of important. And it's super important to don't run using this, because your drone can literally crash. It's kind of difficult. So this was the RMV topic. And right now, I would move into the territory of the APIs that we have and that we have wrapped in our own wrappers. Thanks to Mateusz for his crucial and extensive work. It's incredible. I usually just said what I want, and Mateusz made it into reality, which is great. So what changed? The basic mechanisms that you know are still there. Subscribers, publishers, service clients, service servers, timers, parameter loading, dynamic reconfigure, and transformations. These are the most important aspects of the CPP API. Let's go through them one by one. With some, it's easy. Subscribers, nothing has changed that is significant. Obviously, the API of how you create a subscriber is different. The method looks different. There are more arguments now. You have to use the node pointer. You can specify the QoS and the callback group, but the underlying mechanism is still the same. Refactoring it is easy. And our subscriber handler, which made stuff easier in ROS1, is still here, and it's still the same. So I would say no big deal. I would say use the wrapper because it gives you the ability to check for timeouts from the messages. It obviously gives you the getter for the last message, the information if you have a message at all. There is a new message, and there are a lot of quality of life improvements. So I recommend using our subscriber handler, which is now called subscriber handler, not subscribe handler. So little nomenclature change. With publishers, it's again very simple. I don't think there is any significant difference besides being able to specify QoS and no callback group. That's just the publisher. I think in ROS1, it could easily happen that the publisher would crash. That when it wasn't thread safe, I think. So in ROS1, we had a publisher handler wrapper that try-catched the crashes for you. I think we do the same in ROS2. So I would say use our wrapper for publisher just because it protects you from runtime errors. But there are no big deals in the API for publishers and subscribers. The first problem comes with services. Services are fundamentally different in ROS2, and that is they are asynchronous, asynchronous. In ROS1, services were synchronous. So whenever you called service call using a service client, the call would hang until it fails or until the responder gives you a response. So you would always wait till you know either you cannot be connected or you got the response. And this could be a few seconds easily if the service call on the other side would do something long. It would hang for a few seconds. In ROS2, they have completely switched it, and all the services are asynchronous. So you call a service, the call happens immediately from your point of view, and the code goes further, and you get the response asynchronously using the C++ standard std future mechanism. So you need to then check the future, and if it's filled in, you can extract it asynchronously in some sort of a thread or timer or whatever. In my opinion, this is a problem because our whole system was built using the synchronicity in mind. So whenever I refactored everything, I basically couldn't do it because rebuilding the whole system using asynchronous calls would change the whole structure significantly. I didn't want to do it. So our solution using the MRSlib wrapper is to give you both worlds. And you have to actually specifically select. So if you use MRSlib's service client handler, you can use either call sync or call async method. The call async basically just wraps around the official one with some quality of life improvements, and it gives you ST future. And the call sync wraps around the functionality, and it does the waiting for the result on the inside, and you get a result whenever we know we either have the result or we know the service couldn't be called. I would totally say use our wrapper, even if you want to use the async ones, because there are some idiosyncrasies that we needed to fix. And basically, we made the boilerplate much simpler because the actual result of the native call can be something which can be false or not, and then you can check if the feature is filled. And there are something like 3 ifs you need to use to actually get the result, and the boilerplate is super messy. So we have boiled it down using the wrapper to be as smooth as possible. And the async call, that's totally madness to do it by hand, basically waiting for the STD future. It's nothing nice. So service clients, use our wrapper. If you want to refactor one-to-one, ROS1 to ROS2, switch .call to .call sync. If you want to do it the ROS2 way, use call async or async. So that's the first important change. With service servers, not much has changed, just the need to specify the callback group. Otherwise, it behaves very similarly. The arguments are different. Right now, in the callback, you are not returning the result, but you are filling it into the shared pointer which you get through an argument. So the mechanism, basically the C++ interface has changed, but it still works the same. Again, we have our own wrapper, which I'm not sure what it does, but it probably does something useful. So use that. Yeah, it probably define all of these wrappers by default set the right QoS and callback groups. That's on its own is quite useful. So please use them. Another problem comes with timers. In ROS1, I would totally say use timers because they are kind of robust. They mitigate future problems which you would typically have with native threads. So if you want to do threading, you can, but you have to make sure the thread is throttled properly. It's throttled by the right time, so sim time, wall time, and basically the boilerplate for the thread is kind of big, and you can easily mess it up later. If you do like poor continue in the while loop, you can make an unthrottled thread which suddenly drains 1 CPU core. It's kind of risk. So with timers, this risk is mitigated. However, in ROS2, as of now, if I'm not mistaken, the timers are bugged. It's not maybe the timers, it's the executors on the background which make sure the callbacks are called. Problem is the timers are super CPU hungry right now. I have made some benchmarks and I have decided that it's not good to use them. So we have our own wrapper. And we used to have this in ROS1 as well, which wraps around the timers. And we have implemented a parallel implementation, I mean like similar implementation of timers using our own threads. And this implementation has its own, has the same interface as the official ROS timers. Right now, I would totally recommend, if you want to implement a timer, go into one of our examples or into any of the code in the core. So I'm just going to go into the automatic start node, for example. And I'm gonna check how we implement the timers in there. So, and what you are gonna find out is that in each of my nodes, you are gonna see a little defined portion at the top, which uses directive use ROS timer equals 1. If it's true, we are going to type that timer type to MRS/ROS timer, which is a wrapper around the official ROS timer implementation. If this is false, we are going to type that timer type into MRS/thread timer, which is our own complete implementation of the timer. And since the interface is the same, we can, in compile time, switch between these two timers without needing to refactor any of the codes. And using this in a CMake list, I can just define use ROS timer 0 or 1. And whenever they actually fix it, we can switch this to 1, compile with ROS timers. Until then, I have it set to 0, and we compile with thread timers. And this pours into the actual code where we type def the timer type, and then I'm just defining my timers as the timer type and initializing them and calling all the routines on them like start, stop, set period, and stuff like that. If you use the native ROS timer, you are probably wasting CPU time. And I think it was kind of significant, like the difference of the core of the system with and without was like 3 CPU cores. Like this. The actual reason why it's bugged is the executor on the background, which for some reason, whenever a timer callback is called, it somehow needs to update a state of all the other timers that are within the program. And it needs to like crawl through all the subscribers, and it has to do something with all the callbacks. The more timers you have and the bigger the frequency of them there is, the more operations you need to do. It's like it's not linear. It's like square the number of operations you do because you have a lot of timers and a lot of timer calls. That's the problem with the official multi-threaded executor. They know about it, by the way. There are options how to circumvent this. There is the single-threaded executor, which sadly I cannot use because the core is too complex for it. And then there is other option, which is some experimental, they call it event-driven executor, I think. But I think that doesn't work with Xeno. So right now, we are out of options, and we basically have to circumvent the timer bug. So with timers, just steal this boilerplate from any of the example nodes or from my own node in the core, and just use the thread timer until we find a solution. Now we are gonna get into a danger territory. Maybe before we get into the danger territory, I have a good news. The transformation library, it's still the same, like exactly the same like in ROS1. It's actually the opposite way. It was merged into ROS1 from ROS2 way ahead. So the TF2 that we have in ROS1 is actually the same transformation library that's in ROS2. So there's, I think, no notable difference. The same principle, the same tree, the same static transform publishers, the same topic, and obviously the same transformer wrapper that we have. It's still the same. So good news, everyone. Where it gets complicated is these two last sections, and that is parameter loading, which I think undergone the most dramatic change in the C++ interface of all of them. And I'm speaking about both normal parameter loading and the dynamic reconfigure. So just to give you some concept, in ROS1, parameter loading was centralized. So with ROS core, you would basically run a centralized parameter server into which you could set values of parameters. And if you launched a launch file with param_file being loaded, the launch file executable would actually shove these parameters into the ROS1's param server, and then the node itself would load it from the param server. So it would not load directly through the file, but there was the middleman, the param server. So in ROS1, you could technically set a parameter from a terminal and run a node, and the node would latch into the new value. So in ROS2, we are not centralized anymore. That's the first thing. So this needed to be cut out. But we didn't use this in ROS1 anyway, because it was super slow. If you used our param loader wrapper, that had an option to load the parameters completely like without ROS through a custom mechanism. And we have used this in the core exclusively, because if you run a simulation of 15 drones and you run the core for all the drones at once, all the 2000 parameters would need to be shoved into the single param server. And this was creating a bottleneck. Basically, the whole simulation took like 1 minute to start just because of the parameter server was the bottleneck. So we have not used ROS1's param server. We have run our own param server, parameter loading mechanism in ROS1 already. In ROS2, the parameters are decentralized. So each node handles its own parameters on its own. Like it's its own parameter server, basically. And the mechanism of how the parameters get in the node is completely different. It's much more complex in a way that you obviously populate your YAML files or your launch files. And then in the CPP, you need to first declare that you want to load that parameter. You need to declare what type it is. You need to declare its range, potentially. And then you can sort of somehow extract the value and get it and use it. This declaration is very long. If you have 100 parameters, you are going to probably have 1,000 lines of declaration code. That can happen. And there are some caveats. But the biggest problem I have is just that you need the declaration in the first place. It's very weird. So even in the first attempts of ROS2 integration, we have written our own micro wrapper, like a templated micro wrapper, which basically declares the parameters automatically on its own. So we only have the one-liner of I'm loading a parameter, but in the background, it's declared, it has a type, and stuff like that. And that would be enough, but there are more problems. Problem number 2, the old dynamic reconfigure system, which ROS1 had, and it was kind of a hack, but it was okay. This was merged with the official parameters. So right now, each parameter that you load through ROS into the node magically becomes dynamically reconfigurable. Which means if you just run your node and you check through the services which give you the list of parameters, or you open the RQT reconfigure tool, you're going to see your parameters in there, even though when they are not reconfigurable. They are going to be gray, not changeable, but they are going to be there. Problem number 1. I don't like 10,000 parameters to be there if I don't want to change them. Problem number 2, with the current dynamic reconfigure system is that it's super messy. To use it fully, you basically need to specify the actual name of the parameter in 3 different places in your CPP code. There's the declaration, which I already mentioned for the parameter loading. There is this section where you potentially want to insert value from the code into the server. Like if my code does something dynamic and it changes the parameter on the inside, which can happen, to update the parameter from the inside to the outside, you need to again specify the name of the parameter. And the third and most clear way or weird place is the actual callback for the changes of the parameters. There is now one callback, which was true before. But right now in the callback, you have to do huge if then else. I think it cannot be switched. Can it be? I think it cannot be switched for some reason. You have to do basically, oh, my parameter has changed. Now I have to look through all the parameters that are modifiable and do if then else against all my parameter names. And if it's the parameter that I want to actually react to, or the react to its change in the if, then I need to check if the range fits, if the type fits, and then you can extract the value and use it. And it was super messy. Like, don't recommend even looking at the code of how the parameters are supposed to be used natively. It's a huge pain in the ass. So from a code that used to have 1,000 lines of code and it used 15 parameters, now we would have 2,500 lines of code just because of how the parameters behave. So luckily for us, we have our wrappers. We have a wrapper which handles the parameter loading, which is still the usual param loader that behaves like it did before. And what I really recommend to do is tell this wrapper that the parameters are supposed to be loaded outside of ROS directly from a file. So recommend to do this. Quick example in, for example, the automatic start node. If I open a launch file, by the way, you might not have ever seen a Python launch file. I'm going to get to this. Anyway, if I open a launch file, you are going to see a section which says, I'm loading a parameter, which is called config private, for example, or config public, and I'm giving it the path to the parameter. This is not a path to the file. This is not telling the launch file, please load this file. This is just passing the path through a ROS parameter, cannot be done any other way, into the node. In the node, in the runtime, I'm running the param loader, and I'm telling the param loader, please load a YAML file for which the path is given to you as this ROS parameter. So the only reason to use ROS parameters is to actually get the path to the file into the param loader, and then from here, the param loader prioritizes parameters that are loaded this way over the parameters that are loaded in the ROS way. If you don't do this, it will still load it using the ROS way, but the priority is on the YAML files. This is the same case in ROS1. We had this in ROS1. So I totally recommend to do this, because if you do this, then the parameters will not appear to be reconfigurable. They will not pollute your RQT reconfigure GUI. And most of the parameters are not changeable anyway for most of you. Even for myself, I have, I don't know, 50 reconfigurable parameters in the whole core. And the whole core has 3,500 parameters if I sum it up. So few percent. So that's the first important aspect. Do this like we did this in ROS1, and you are going to be happy, probably. And I think there is a news from Matouš that right now we can already load, how was it, the degrees and radians converter that was there in ROS1 also works with this.
It only works with this. Actually.
It only works with this, okay.
Because the ROS, native ROS loading no longer supports them.
So yeah, so I had like param, and then was it deck and 90, and it converts to radians on the inside.
Yeah.
Okay, it only now works for this. Okay, good.
This used to be like ROS functionality.
Yeah.
And I wanted to use it also in like the raw YAML loading, so I formatted it, and then I wanted to do it in ROS2, and I noticed that it no longer works in ROS, so I don't know.
Yeah. Yeah, so param loader must have. Without it, you're gonna totally waste your time, waste your code space, and you're gonna probably go mad. I don't even want to show you how it looks on the inside, what we need to do to actually load the parameter. It's a waste of time. Just don't do it. Don't do it. What also waste of time is the dynamic reconfigurable thing. If you want to do it the native way, you're wasting your time, because the best wrapper that we have, in my opinion, is the new and flashy DIN param manager, thanks to Matouš, which we invented to basically simplify dynamic parameter configuration into a one-liner. I'm gonna find a node where we have it. So
just a question. How with the parameters? You need to specify the type? So when you are specifying, for example, it's a real number.
No.
With a dot, like 1.0.
With param loader, you don't have to specify the time. It's overloaded for all the standard types. So just
I know that that's the issue of ROS2 when you use default, you need to do all the time .0, for example. That's real. It's a serial number. It's not.
with param loader, it will not break. I think the parameter can like typecast int into double.
Okay.
But with native ROS, this is problem, and it's even problem with like the Python implementation of ROS. So if you call a service which accepts XYZ float or double, you actually in the Python code insert 0 without .0 in the variable for the service request, it will just crash because it cannot typecast into double in runtime, and it's
So this is solved by param-loader.
yeah, this is solved by param-loader, but beware, the same problem can happen to you in Python, and it's super cryptic. It's hard to like decompose what actually happened, that the problem is in not saying 0.0, but saying 0 into a service request like this. Yeah, madness. A lot of the errors we are going to be getting are cryptic. Be prepared for that. Yeah, so for dynamic parameter loading,
Find it in the waypoint flyer.
oh yeah, examples. Let's do it. Did I have it in here? I don't have it in here. I'm gonna show it through controller, for example. So you are just gonna instantiate the dynamic parameter manager, and for the manager, what you can do is it gives you the ability to register a parameter. You give it a name, which is what's gonna appear in the architecture configure menu, and then you give it a variable. And the idea is that for most parameters, you actually don't care about callbacks. You don't care about being notified that the parameter change. In my own code, most of the parameters are sort of one-to-one reflection of the variables which I'm using somewhere in the code anyway, and I don't need to know that they change. I just need the variable to be updated. And this thing, what it does, it automatically updates the variable for which to give the reference to the parameter manager. And whenever the parameter changes, the variable changes under the hood, under a mutex which you give to the parameter server in the initialization. So somewhere in the beginning, I'm initializing the parameter manager with mutex, and then you can just extract the variable under the mutex, and it's gonna always be the updated one. So for example, for gains for a controller, I don't really care about being notified. I just need the right gains. So for that, it's a one-liner instead of multiple places where you wanna be checking the parameter name. It gives you the option to set the parameter value from the inside out if you want to. There is a quick way to do that somewhere in the examples. I'm not sure if I'm gonna find it now. Yeah, some method which is called update to ROS, which is gonna update the parameters from ROS to the server. And there is a quite neat way how to preload to the default from the param loader. So you can basically extract the parameters from the param loader, give it to the dynamic reconfiguration manager, and it can default the values if you want to. That's this one-liner. Basically, they are stealing the internals of the param loader and giving it to the dynamic parameter manager, so it knows about the parameters as well. And if you want to have a callback for some reason, whatever, I'm ticking a box for stopping a simulation in my simulator, so I want the callback to actually stop the simulator proactively, you can register any number of callbacks to all the parameters. They can be different callbacks, so your code can be nicely separated. You don't have to mix everything together. So for the rare cases where the callback is welcomed, you can use it. And in the one-liner, you can also specify the ranges for the parameters in the one-liner. So in this case, I have a range of an integer 0 and 1, so it's a discrete thing. Yeah, very, very simple, very easy, much simpler than it was in ROS1. I think this should be the native behavior of the API. Anyway, there are things which we couldn't fix, and there are huge regressions. Regression number 1, we cannot use parameters of the type enum anymore in dynamic reconfigure, which I am crying over, because I used to have many switchable things with an actual name in it. So in the server, it would be obvious what you are doing. Right now, we have to use 0, 1, 2, 3. And the bigger, or also quite a big problem, is that the groups for parameters has disappeared. They have disappeared. So I used to group my parameters by intention, so lateral gains, horizontal gains, whatever. This is now gone. Right now, the parameters are all in one box, organized alphabetically, no enums, so it's like 90s, basically. It's bad, but it can be used. It somehow works, thanks to the dynamic parameter manager. So these are the wrappers. I hope I haven't forgotten. We have, as I showed before, basically a wrapper for the node itself, which I totally recommend to use. And there might be some more, but there might be minor. So the native API changed, sometimes very significantly, and I basically never use it natively. There is no need, and I don't recommend it. Yeah, the wrappers solve so many problems, and some of them are minor, but they can be problems and they can be hard to find and hard to track. Yeah, so that's the native C++ API. Obviously, we don't have a similar wrappers for Python. So in Python, you are forced to use the native API, which is not that bad, actually, but I wouldn't use it for anything serious. So I wouldn't probably found the problems in the first place, but there might be the same problems. So any questions about the C++ API? Yeah, if you are interested in examples, you can either scout through the MRS VAV core, that basically serves as a huge example, or we obviously have an example package. If you remember, we used to have MRS core examples repository, which has its equivalent in ROS2. It houses both C++ and Python. The C++ examples are the more dominant here. So we have an example for a controller plugin, estimator plugin, tracker plugin. We have an example on how to use the plugin with library. We have a waypoint file example. That's the let's show how everything works. I wouldn't say necessarily it's a good boilerplate because it has everything in it, but it definitely is the place where you should steal from. And then we have example waypoint file native, which doesn't use MRS late. If for whatever reason you still need to use the native API, here is an example of how to use it. All of these examples include tests. So whenever you are copying these and basing your project on them, you can already start using the proper ROS tests for testing whatever you work on, either through unit tests or integration tests. Super useful. We also have Python example in here, some minimalistic, I think it's a grid-based flyer sweeping generator. For computer vision people, we also have MRS computer vision examples. Again, switch to branch ROS2, which contains C++-based edge detector using OpenCV, and Python-based blob detector, again, using OpenCV. Important with these Python ones, or with this one, is that this already integrates mechanism for creating virtual environment, which is then used to run the stuff. Kind of important because in Ubuntu 24.04, you cannot install libraries globally anymore. You are supposed to use virtual environment. So all of your nodes need to run in virtual environment. So this is the boilerplate for you if you want to start. There is an important trick you should know about. Whenever you are creating the Python environment, you are supposed to say -- system side packages to the environment such that it basically can tap into the system install dependencies like ROS. And it will only tap into the installed ones when you actually install them in the environment. So totally use this. And this is, I would say, in quite a good shape and ready and nice. So core examples and computer vision examples, they are linked from the homepage, I think, from the Ubuntu homepage, GitHub homepage. Yeah, so that's the API. Let's move into a few last sections. The launch system. In ROS1, the launch files were predominantly XML, which is still the case for ROS2, but there are more options. Option number 2 is YML. You can have YML launch files, and you can have Python launch files. I have literally zero experience with XML and YML in ROS2. That's because in the time where I started the migration, it was said that the ROS2 has the superset of all the features, and the YML and XML files lack some features. I didn't want to find out myself what they do lack, so I jumped directly into the Python to basically open the doors. So all of our launch files are in Python, and they work. Sort of, I have not found a problem that I couldn't replicate from our ROS1 launch files. And there are even more features we can use now. It's more powerful. I don't know what we are lacking in YML and XML. I don't want to invest the time myself, but for some simple projects, you can totally use YML files. Like starting a static transform publisher, use a YML launch file. Why not? It's better than a shell script, probably. But Python, I would say, is the way to go. The cons of Python is that it's very bad looking, and every person will probably run a different style of Python launch file. So basically, anytime I'm looking at someone else's launch file, I'm like, how does it even do? How is it? Because it can look very differently. But point number 1, the Python launch files are primarily declarative. It's not a script that would do arbitrary stuff and then in the end start the stuff. It's more of a method which declares a structure that in the end is going to be parsed by something else that starts the stuff. So you cannot easily do arbitrary computations inside, which would produce arguments, parameters. There are limits, and due to these limits, you are forced to use some mechanisms that are provided by ROS libraries. So in each launch file, we are going to find a lot of imports from some launch library, and even doing stuff like if then else with some of the components requires using some if else substitution function which does stuff. Yeah, these 4 lines are the same thing that we used to do as a one-liner, which says if an argument is empty, this argument is gonna contain empty thing, otherwise fill it with some other argument. It was a nice one-liner in XML. This is for the custom config. Basically, if the custom config argument is empty, make it empty. If it starts with a slash, prepend this, something like that. I don't know. It's messy. A lot of the stuff in the launch files are messy, so reading an existing launch files can be a really pain, but in some time, you are gonna definitely develop your own collection of concepts, which you just copy and paste everywhere. What's important is everything is possible. And in the end, in the launch file, you are gonna produce a structure which resembles what we had before. So we are basically specifying, yeah, I want a composable node from this package. It's gonna load this plugin under the namespace. Like this is still the same. It's just some like JSON structure, basically, or partly a JSON structure with arguments and remaps, and everything you are used to is here. It's just a messy declarative Python. So right now I'm in a kind of a no relationship. I used to be in a hate relationship. Right now, I know that what I need is doable. I somehow learned to structure my files using these folds. I have constructs for loading arguments and passing them as parameters. You're probably gonna deploy the same concept. So enjoy. The problem typically is that you are forgetting something, typically this return at the bottom. If you remove it and run your node, it's not gonna tell you what's wrong. It's gonna tell you it cannot parse some none type somewhere. And it's sometimes very difficult to find what's wrong. But I think you just need to bite it and learn to live with it. It's always good to start with launch file which works and you know it. So again, steal from our own examples, steal from the code that we have, and it's gonna serve. Yeah, so these are launch files. Yeah, as I said, use XML or YAML if it works for you. When you get stuck or hit the wall, you can always get back. Little note, you have to end the name of the file with .launch.py if you want this file to be locatable through code completion in your terminal. If you don't do this, it will not suggest the file as a launch file. So if you think it's like abundant, I mean, like it doesn't have to be there, now it's not going to be found through the launch system. Not nice. Yeah. I think there used to be a time where you couldn't run a launch file as ROS2 launch / a file from any directory. I think Vojta told me it's possible right now.
That's right.
I hope you're right.
You can just copy it anywhere and try it.
Yeah, let's try. ROS2 launch.
You need to write it by yourself.
You need to write it, okay. What was it? Gain manager launch. ROS2 launch. Yeah, good. It does something. Yeah, so this is solved. Otherwise, I have nothing else to say. We have one important construct that I didn't yet use anywhere, and that might be useful later. We have a way how to remap topics from a custom config using a launch file. So this is going to be the future. If I like use it, you are going to be able to remap topics for a node without modifying the launch file and without relying on the programmer of the launch file to actually give you arguments to modify the remaps. Basically, the launch file can load the config in the runtime, parse a specific section about the remaps, and then apply the remapping after that. So for some stuff, the launch files can be really more powerful than in ROS1. Otherwise, it works. It somehow works. So that's launch files. Yes, small things about command line interface. Code completion, I have already nudged. You need to either source PowerShell additions or do some other stuff to have it. What's kind of tedious if you run a simulator? So I'm going to just run a simulator. MRS multi-rotor simulator, Tmax, MRS1 drone. If you want to echo a topic, you can obviously do ROS2 topic echo like you were used to with the same. But there is but. So ROS2 topic list will tell you the topics, maybe. Yeah. Where is the drone? Yeah, I think my laptop isn't actually very happy from the online stream, basically. So yeah. So will it fly? Forward. Let's fly, please fly. Why? Huh. Oh yeah, my laptop is just not making it. Anyway, I have the topics. It should be doable. So ROS2 topic echo, what you are used to, UAV1, estimation manager, bottom main. By default, it prints like this. Again, going back to many default decisions in ROS2 are just mediocre. If you want to get back into your normal print, you have to do --, flow-style. So if you find a problem, don't be afraid to dig deep into how the stuff is supposed to be configured, and you probably need to change some arguments to work like you were used to. One important aspect is calling services from a terminal. With ROS1, this was totally doable, and it was fine. With ROS2, it's more complex. You can totally do ROS2 service call UAV1, I don't know, UAV manager / takeoff. Then tap will fill in the type or suggest a type. And then you are supposed to provide a JSON dictionary, which contains the contents of the message. And for even just a string service, you need to know what's name of the variable in the request. And it's kind of pain to call services from a terminal. Because who can write JSON dictionaries from top of their head? So for service calls, I'm usually just creating a script, Python script that does this for me. You can find these scripts in the MRS multi-rotor simulators, MRS one drone example, the most basic example. I have scripts to do everything, setting gains, go to lands, pitching controllers, because using a Python is basically simpler than trying to do it from terminal. I just don't call services from terminal. It's a pain. It's even better to run the RQT GUI, select the service, and fill in the values in there. So that's TUI. Yeah, we have already mentioned how to use the libraries with the middleware and Xeno. Okay, we have skipped many of these because we have already discussed this. I would like to mention tests. I think rarely any of you have written a test, a ROS test for your stuff, which is fine if you do development. I would totally recommend to think in the mindset of testing. These are not just unit tests, which might test individual functions. This is typically the case for libraries, like MRS libraries have tests in the form of unit tests. But then there are also integration tests, which can start multiple nodes, and they can poke into the nodes, and they can check what happens. Most of the MRS core actually runs integration tests on the server, and before it's merged and compiled into the stable PPA, it goes through the test. So it's sort of guaranteed that the basic functionalities will work, and that we are not going to be facing issues of, oh, the system doesn't do go-to, or trajectory tracking is broken. Like, it's very probable that it has been tested before compiling it. And I would totally recommend you adopting this mechanism as well, because it clears your mind if you have the tests, and whenever you do changes to your code, it will prepare, or you will prepare for your future self a mechanism that you just run. You can go for a coffee, and in 10 minutes, you will know if you broke it or not. ROS1 had a test system which was okay, and I would say that ROS2 has a test system which is even better. You can define unit tests quite easily. Definitely check the MRS lib if you are interested in unit testing. But I would say unit testing is not that useful. Besides testing libraries, definitely. Like low-level stuff, yes. We want to be sure that our subscriber handler actually does what it's supposed to do before we use it. But for most of you, unit tests are probably too fine-grained and too dislocated from what you are doing in the big picture. Integration tests is where the system shines. With integration tests, you can define sort of long files which will run your stuff with other stuff like the MRS system, and you can define something which I call an interactor, which is a node which is going to poke in the right places to sort of incentivize behavior. And then you can check for results. And you can check for results either directly through ROS. So the same interactor that's doing the poking can be subscribing and checking, my system has moved to the right position. Or what's new in ROS2, you can actually test for std output, which is super nice. Like if you are diligent with your prints, and you know that when your system prints that the goal has been reached, it means that the goal has been reached, you can write the tests in a simple way where the poker will just poke, and then you test for std output if within the first 20 seconds of the runtime, the message goal has been reached, has appeared. And this is super, super useful and quite elegant. So if you want to learn how to do tests, again, the example packages like the MRS core examples all should contain some minimalistic form of a test. So for example, if I jump in the waypoint flyer, for example, okay, that's switch branch to ROS2, don't forget. If I jump into the waypoint flyer here, you are gonna find a folder called test, and in here I have some scripts for running all the tests or one specific test, and here I have a folder tests, and I have each test in one folder. So there's now one folder called waypoint flyer test, quite a generic one, which contains a CPP code, which is the poker node, the node that's gonna actually poke into the system. In this case, it's a class that extends some generic interface for the MRS system, which allows you to do basically anything with the system. And I use this to run all my tests. So I basically implemented the ROS counter interface into the MRS system once, and then I'm using it in all my tests. And the test has one method called test. It instantiates one for sort of a handler for the drone, which allows me to do stuff. And here I do stuff. I activate the drone in midair. You are not losing time with takeoffs if you don't have to. And after 2 seconds, I'm calling a request for starting the node to do the stuff. I'm waiting 2 seconds, and then I'm infinitely waiting for something. What is this thing? Yeah, so basically this just calls a service that starts the waypoint flyer to do its thing, and then it just waits and does nothing. So if I assume correctly, in this Python file, which basically acts like a launch file, at the bottom, so here I'm starting all the important stuff for integration test. I'm starting the MRS system. I'm starting the simulator. I'm starting the hardware API for the simulator. I'm starting the waypoint flyer, that's the node that's being tested. And I'm starting, blah, blah, blah. And then there is a section, Python section, which allows me to check for results within some time. And one of the checks which can happen here is the check for standard output. I'm not sure if it's actually used here. I have basically blindly opened one test, and it might be the wrong test to show you. Yeah, here's a commented code which can check for return codes. And somewhere in here, yeah, so sorry, this test doesn't show you how to parse the standard output. This basically just tests if the waypoint flyer was initiated. It's not comprehensive, but in some other packages, you are gonna find, so definitely go through all of them, you're gonna find a test which checks for the outputs. So probably, I would say a tracker plugin test might be it. So just quick check. If you are interested, definitely let me know, and I'm gonna point you to the right direction. Yeah, not here. Anyway, these tests are automatically executed in the build pipeline. So if you are gonna contribute to core package, we are gonna run tests, and they are gonna be executed if they are present in the package on pull requests into your own package. So they can be automated on GitHub quite easily. So I'm quite happy with the testing mechanism. It's super useful. In total, we are running like an hour of tests for the whole system before everything is merged. So it's super useful. Yeah, this gets me to the build pipeline, which works like it did for the ROS1. So we have our own PPAs. We have actually two PPAs which you can use. One is for the unstable system, one is for the stable system. The stable thing can be few weeks behind the unstable thing, depending on how eager I'm to merge new stuff. The stable thing should always run, always work, always be internally consistent. So I would say always use the stable PPA. The unstable PPA is there for people who are doing something with the core and are expecting to be installing fresh stuff on a daily basis. So it's typically myself if I'm doing development. If I push change into a package into the sort of master branch, it's compiled within like 10 minutes. And then in 10 minutes, I can install it on a drone using sudo apt install or build a Docker image from it. The problem with the unstable one is it can be internally inconsistent. If someone pushes some like ABI breaking change, some binary interface is different, then it can totally break runtime. And it refreshes itself every day, every night. So after every night, the unstable one should be again okay, but it can contain totally bugs. And nobody guarantees that the tests are passing on the unstable one, whereas the stable one, the tests are passing always. So yeah, this is the same mechanism as with ROS1. One little difference with Docker images. Now there is an option for each package within the pipeline to generate a Docker image. Basically, if there is something special which cannot be done through that package, and you need a Docker image, there is an option to just add a Docker file, flip a switch per package or per repository in the pipeline, and the pipeline will once a day generate a Docker image for that specific package using the latest either stable or unstable commit. Basically, the only package that is currently using this is the MRS UAV system package itself, the main package. So every day you are able to download the latest version of the FEE-CTU MRS UAV system stable or unstable, which is basically just the MRS UAV system in a plain Docker image. But if you want to your own Docker image for your own package to be built automatically, you would need to put them on GitHub and make them part of the main build pipeline, which is possible. Yeah, talk to me if you want that. So this is the case for like the UVDAR guys. This is totally possible. So right now you can install systems with Docker images. There are 3 tags currently. There is the stable, recommended, unstable, non-recommended, and then there is the latest. And the latest, the where is still ROS1. The latest is the latest ROS1, and then we have stable, unstable, which is always like latest ROS2. So that's build pipeline. And now let me check quickly about the actual state of the MRS UAV system. So what we have, and what we don't have, and what we won't have, and what we might have. So what is ready? The core of the system is 100% ready and usable and good to go, with maybe only the small exception of a speed tracker or something like that. Stuff I basically deemed broken or not very useful, I deleted, which is maybe only the speed tracker, because I think like the speed tracker should be rebuilt with a different concept. But otherwise, it's still the same. The stuff you know is there, and it's even upgraded in some sense. Just last week, we have finished refactoring of the Octomap mapping and planning. So if you intend to do some mapping and planning, you can. But it has never been tested on a real drone, beware. But it has been tested in simulators. It looks like it's working with both Livox and Oster. But it's in quite a fresh state. We have a point LIO core, so LiDAR odometry using LiVox. We have already tested this on the sprint competition. It works quite great. I have actually refactored heavily both the LiVox driver and the point LIO. So the difference between ROS1 and ROS2 version is like night and day. The ROS2 version is better in every way. Like right now, the point LIO, the LiVox driver publishes both the proprietary message and the point cloud, the ROS point cloud. It publishes also the unmeasured rays, the free rays. It can run one LiDAR or multiple LiDARs, and in the config, you can even like rename the LiDARs based on their IDs. So they are gonna be presented with whatever name you want them to be presented with. Like a lot of quality of life improvements. I would say this is in a very good state. So GNSS night flight with LiVox, easy. OpenVINS, it's also refactored. It has been also tested, I think, in both the MRS camera module fashion and the RoboFly fashion. I haven't actually flown with a RoboFly using the OpenVINS, but we have RoboFly-based BIO module which runs the OpenVINS in the same way. So actually running it on a RoboFly is an easy thing, but I haven't done it myself. But I don't think anybody here wants to fly GNSS denied to RoboFly. Am I right now? Good. Yeah, the LiVox 3 the driver has been heavily refactored. We have our own version, which is better in every way. The Oster driver has been somehow refactored, and it somehow works, and we have used it. The BlueFox driver also has been refactored, and it somehow works. RealSense driver, we use the off-the-shelf version, and I think it works, but the actual launch files might be sort of generic, so don't expect the names of the frames and frame IDs to be correct, or the namespaces. Because we haven't used RealSense personally in the group. So if you want to fly with RealSense, it will work, but it might need some work in maybe polishing the long trials. What is not ready? ALOAM. And there's a question mark because I don't even think we are going to ever refactor it, because in my opinion, the point LIO is better in every sense. And comparing ALOAM with Oster to point LIO with LiVox is incomparable. Point LIO is much better. LIOSAM, I have personally never saw a drone flying with LIOSAM. This was some Matej's work. I don't think if it's good or bad, if it's worth doing or not, hard to say. So I'm not going to do it. If someone needs it, he's going to make to do it himself. Hector Slam, is there anybody flying with Hector Slam? Good. So no. Multi-modal inertial navigation system, again, some Matej's thing. I have never seen it flying. Anybody wants this? No. So then until somebody says yes, no, we are not going to touch it. The old optic flow built by Victor, I have not ran this for years in ROS1, so not interested right now. The precise landing mechanism that I have developed, we have not needed yet, but might be helpful. So maybe someday later, when there is no pressure for projects, somebody could refactor this. Bachelor camera driver, have not touched the camera ever, so I don't know.
It's working out of the books.
Okay.
Only the one
Awesome.
files.
Good, so that's a good thing. RP LiDAR driver, nobody cares probably anymore. OGNI camera, we actually had it on the sprint competition, and we had problems with the driver. Even though it's connected through Ethernet, we had it not connecting until you do several power cycles of the camera. I'm not sure what's wrong. We were running the upstream version of the driver without any changes. But it's working. Like when you eventually make it run, it's working. So and obviously the namespaces are weird and the frame IDs are wrong, but in the end it works. MRS utils are work in progress. I think Philip is working on them. Path loader and trajectory loader, for me, this is super low priority. And these packages are so old and so bad on the inside that I would love if anybody could maybe rebuild them completely from scratch without like biasing itself to the old ways. These are basically nodes which just take a file and somehow shove it through a service call into the system. And I think they could be done better. Yeah, we built this first in 2017 for the MBZRC, and since then, very the same. So I would change them if possible. So they are not done yet. And what's completely missing, and this might be a deal breaker for many of you, is the way how we managed static TFs for our sensors. So we used to have this sensor.launch, which parsed the variable sensors, which gave it a way to like enable some of the sections such that you can run your TFs and your sensor drivers. So we would insert something like a real sense front, and based on the actual drone frame type and that is front, it would actually start the right TF. This was okay for ROS1. I haven't had the capacity to try to do it in ROS2. Since the launch files are so different and so messy, I don't even want to do it using the native Python launch files. I haven't attempted to do it. And my idea is that if we are going to resurrect this mechanism, I would probably build it outside of the launch system. I would build some sort of a program or script that does the decision-making in Python or Shell. And then on the inside, it's going to actually execute ROS1 of the static transport publishers. But in ROS1, this could be done easily in the single sensors.launch file because the XML was so nice, sort of. But in ROS2,
You can still use the XML.
with the conditioning
It just
and string parsing, which uses Python on the
I
inside.
think the issue with XML was that in the previous version it was buggy, but in Jazzy it's as a standard as
Okay.
well. So maybe worth to try.
Okay. Anyway, I haven't touched this yet. So right now, if you are going to fly with your drone and you're going to have your sensors on it, you have to yourself make sure you are running the static transform publishers yourself with the right parameters. Nobody's going to do it for you. So yeah, tough life. But it's like no big deal if you are familiar with how static transform publishing works. It's the same as in ROS1, basically. So that's what we have and what we don't have. An important part of what we have are simulators. We are currently able to run using 3 simulators. The MRS multi-rotor simulator, which is the same as in ROS1. It's part of the core. It's minimalistic. It works quite nicely. Then we have Gazebo, thanks to the guys in Fly for Future, thanks to Vojta and Peter Stibinger and all the other guys. I'm not sure how many people actually contributed, but it must have been a hell of a job because the Gazebo system is very, I would say, very different. Is it? Yeah. So right now, you can fly with Gazebo in a similar way as with ROS1. So we have still the drone spawner, which accepts arguments for the sensor parameters and sensors. But the Gazebo is very different. It's actually a different version, sort of. It's called Ignition Gazebo. Right now, it's the Gazebo, but it used to be Ignition Gazebo. It's more greedy for computer resources, but it works. You can use lidars, cameras. I have quite a mixed experience with actually starting the simulators. There are some sleeps that you need to run before you actually try to arm the drone. But I think this is due to the actual PX4 SITL that we have there. It behaves just like in a real world where it decides that it doesn't want to arm anymore, and you need to give it some time. So if it doesn't take off, just restart the whole sim. And maybe you might get lucky. I'm not sure if I should even try to run it here because my computer is not happy. I have load 15 just sharing the screen here. But you can totally do ROS-CD, MRS UAV, Gazebo, simulator, find the Tmax session for for one drone, just like you are used to start the session. And maybe I'm training the drone, and I will give like 5% to the drone actually taking off in this CPU load, but let's wait. Yeah, so this is totally doable. Give me my drone. Yeah, a lot of sleeps, drone. And now we have to pray to the god that the PX4 will actually connect happily, and then when the time comes for arming and takeoff, that it will actually do what it's supposed to do. I think with this CPU load, it will fail somewhere in the middle. Yeah, side. Madness. Very realistic. Yeah, exactly. So something didn't work yet. But my computer is dying right now, so load 30. That like don't expect it to run with load 30. But otherwise, it's quite decent. Yesterday I flew with LiDAR and mapping, and the simulator took just like 2.5 hours, so probably fine. So that's doable, but I haven't used it very much myself. So yeah, we are gonna find out. And the stuff that I use most of the time is the Flight Forge that we developed with David and Honza, which is, I would say, work in development, work in process, but it's super powerful, nice visuals, good LiDAR, quite okay performance. For us, this is the daily bread. If you want to use it, it's totally doable. I'm not gonna attempt to run it here because the computer would probably die, and you have seen it before, I think. So these three are usable, possible. I'm not sure about the state of the worlds in Gazebo. There might not be that many worlds like we used to have. I'm not sure about the state of the drones, if we have all the models, but good. So we have many models. Yeah, so please start to use it, give feedback to the guys. So far, not many people have done this. So simulators are totally doable. Now about about deployment. You have still the options for the deployment on a real drone that you used to have before. So the native deployment, the native installation, it's basically the same as before. You have 2404 running natively on a drone. If you can actually install 2404, then we provide you with an example Tmax session in the exactly same location as before. So MRS UAV deployment will contain folder Tmax with just flying, where you are going to find the Tmax shell script, a record script, and a place for config files. Like the interface to the MRS system hasn't changed, so the config files have still the same structure. Although some things have changed, like some namespacing, so you cannot definitely take your custom config from ROS1 and just use it in ROS2. You are going to need to do some minor adjustments, but the mechanism is still the same. So that hasn't changed. The contents of the Tmax script is basically the same. But again, you cannot use an old one and just replace the programs, because what has changed is the mechanism of like recording ROS bags. There's a little different mechanism. So what I would totally recommend is take the new example Tmax session and insert your ROS2 launch and your configs into it. Don't do it the other way. Don't try to fix your old session with the new one, because you are probably going to forget something from the new one. So yeah, within the session, as said before, we are exporting the RMV variable, and then on the inside, it's kind of still the same. What's different is how we record ROS bags. So the record script is different. Again, don't use your old one, write a new one. because the script is different and the way how we exclude topics is different. Even the format is different. The how-to is written in here in the comments. The way how we use wildcards is different. Before we wrap them in some brackets, now we don't wrap them in brackets. Now we even can use like an end line $sign. You have to use it if you really want to specify that there is a end line here. So this is different. Write your ROS1 record scripts again and make sure you are recording it right. The ROS1 format is different. It's some sort of a database called MCAP, actually developed by the people who developed the Foxglove visualizer. By the way, recommending Foxglove visualizer. It's very powerful. So we are gonna need to learn how to work with ROS1 again. But the examples are here. The deployment example is here. If you take a drone which is installed by the hardware team and you run just flying, it should be just flying. It should be working. You should be good to go. No caveats here, I think. You can also use Docker-based deployment. I'm recommending Manuel's lazy Docker system, which I really like, in conjunction with running your compose session on your laptop and actually exporting the Docker host such that it runs on the drone. It's super powerful because your drone is just an empty vessel and you can have every piece of configuration on your laptop. We have prepared some nice like example sessions, which are quite powerful, which can even facilitate custom compilation of your own software on your own laptop, which is then magically transported onto the drone without you needing to lift a finger, and your compiled stuff will just run on the drone on its own. Like it's super nice. Obviously, it has its limits. You cannot easily debug through Docker on the drone. Like if your program is crashing and you need to run it in GDB, it's hard to do. And if you have a super complex system of 30 packages, compiling it on your laptop and transporting that to the drone might be counterproductive. So there are limits. I would use the lazy Docker system with only like small changes being done to the configuration. If you really need to code and compile again and again, it's better to work with native installation. And you could also use the Portainer system, which stores everything on a drone and it gives you nice web UI such that any other person with the drone can actually start it. We are distributing the RoboFlies with this, and it's okay. There is low flexibility. It's kind of clicky, but it works. For some use cases, it's okay. So all of these deployment mechanisms are possible. Use the one that is, the most comfortable for you. One last point on my list is camera calibration. If you are a vision guy, you are probably calibrating your camera. You might use the ROS's calibration tool, or you might use the Caliber tool, which is better, supports by a variety of models, and is typically used by other softwares like OpenWinds. So basically, you are forced to use Caliber. I used to have a Caliber Docker repository, which, if you go into C2 MRS/Caliber Docker, it's wrapping the Caliber software in Docker in such a way where you don't actually have to compile it on your own laptop. This worked for ROS1. Thanks to Philip, we already have this working for ROS2 as well. Not in a way where we would like refactor it, but Philip actually made another input vector into the software in a form of a folder with images. It used to load ROS1 bags. Now it loads folder with images. And there is quite a neat way how you can just extract images from a recorded ROS2 bag, shove them in a folder, and run Caliber through Docker on that folder, and it will spit out calibration. Super useful. And I've been told that Philip is going to work even on removing this step completely, that we are going to give the software the bag, and it's going to just give you out the calibration. That would be like awesome. So if you need to calibrate cameras, this is already ready. Without it, it was very painful to like calibrate cameras because of the dependency on ROS1, ROS back. converting the bags is not super simple. So that's basically end of my list. One last point that I basically remembered now is bridging. You might think that you might be able to bridge ROS1 and ROS2. No, because ROS1, the ROS2 that we use and the ROS1 that we use is so far apart that you technically cannot bridge them. There is no way how you could run one program that would subscribe to ROS1 topics and produce ROS2 topics in ROS2 that we use. It's not possible. Don't even think about it. You might be able to bridge using some custom communication protocol, like Xeno. You can run Xeno natively, like on your own. But I think the time investment into the bridging is just a waste of time. It's better to use the time for actually moving, transitioning. Yeah, so don't even think about it. Yeah, also like converting ROS1 bags to ROS2 bags is somehow possible. Going back is harder. So if you have some old data sets, you can update them into ROS2 somehow. Otherwise, just migrate as soon as possible, be done with it, and then you can move on and work quite productively. So that's all I wanted to say without going into some deep showcases. So yeah, what do you want to know? I still have half an hour for you before I disappear. So let's speed up the discussion.
Yeah, I'm interested who's going to remote deployment of ROS2 drones. Okay. You?
Yeah, for the function, for the project, you know, we pitch.
I'm very interested in that because
Yeah.
you know, this is enough, and sharing all this information configuration.
Xenon is fine. Like I worked with it when I was in Canada, and it was like actually super intuitive. Like you set it up and it just works. It's a great thing.
For one drone or for multiple drones already?
Yes. I mean, we didn't have multiple drones. We had luckily like UGVs and drone, but it's still talk to each other pretty nice. And there were even like 5 different computers on the UGV itself, each like Raspberry Pi handling the 35 sensors, and it was all connected with Xeno. So it's really cool.
Yeah. By the way, on the sprint demo that we did 2 weeks ago, on a drone we had a Mac and a Raspberry, and on the Raspberry we run stuff in Docker through the laser Docker setup, but we actually run it from the Mac's tmax session through Docker host. So we spun up a tmax session. One of the panes was Docker Compose up onto the Raspberry, and the Raspberry would start its own software with VIO, and it would communicate through Xeno, and it worked fine. It's totally doable. So right now, even having more computers on a drone is less pain than it used to be before with ROS1. I remember with ROS1, we have spent many days just making sure our cores are communicating either through some middleman like the Nimbro or natively, but then you are relying on one computer to actually sustain the other one. With this, it just works. It's distributed. Everybody talks to it on its own, and it works. So Xeno, totally, yeah, fingers up. Yeah, so multi-robot stuff is Fronta. Yeah. Okay. Anybody is gonna fly with RoboFlies? So regardless of the problem,
What is better shipping preparing it like for feature? It's RoboFlies. You're gonna share the drones in the end.
I'm not sure what he's doing. Maybe it's customers RoboFlies.
It's online.
Peter?
Yeah, we'll be shipping 5 RoboFlies to Singapore, so we'll be flying them as well.
Sorry, could you repeat that? I just enabled the sound.
Yeah, we will have 5 RoboFlies that we will ship to a client.
But it's ROS1, yeah?
ROS1 or ROS2?
Yeah, that's ROS1.
Okay. Yeah, so regardless of, like with RoboFlies, there are 2 issues. Issue number 1 is the arming issue, which we used to have. I'm not sure if that disappeared or not. Most likely, yes, that's good. Then we might have another issue, and that is computational power. because my gut estimate is that anything you implement in ROS1, in ROS2 is gonna cost something like 1.5 times more CPU draw than in ROS1. And it all depends on how many topics and services and timers you have. So simple nodes that have one publisher and nothing else, so sensor drivers, they seem to be doing fine. Other simple nodes like point.io, odometry, which has one subscriber, two subscribers, three publishers, it's also like 1-to-1, but the core of the system, which has 80 publishers, 40 subscribers, 8 timers, that looks like it's having like 1.5 to 2.0 times more CPU draw than before, which is probably because of some overhead due to the RMV, due to the communication, and some mediocre implementation of the executors, which are there under the hood. So on RoboFly, I've actually flown with RoboFlies in ROS2, and I think something like 40% of the CPU was just consumed by the core of the system. Before, it used to be something like 25%. So it's totally flyable, but less CPU resources are left for your own stuff. But it's totally doable. By the way, the CPU load that we are currently seeing, it's worse, but I think the computers are getting better faster. I have flown with the latest Asus NUC, and it was amazing. I have basically seen like no CPU. It was not even visible on the graph, the stuff that the core of the system drains. So like the computers are getting really fast. Obviously, the problem is with the weak ones. The Raspberries, the NVIDIA Jetsons, the Tegras, they are CPU-wise, they are bad, but with Asus NUCs, all right. Yeah. More comments or questions? Please have questions now. It's gonna be simpler.
Regarding the tests, we already saw that the simulation can be launched with under load differently than without load. Here in your laptop, I guess it used to be running smoothly. How do we tackle this in our tests? How do you tackle it in your tests?
So normally I run the tests with real-time factor 1, and it's not a big deal. Obviously, the computer is not under heavy load. Even on the server, on GitHub, real-time factor 1 is okay. If you have a problem, if you, for example, do a test with multiple drones, you can dial down the real-time factor to 0.1. It's gonna take more time, but it's gonna totally give the system some room to breathe. So I would just specify custom config for the simulator, real-time factor 0.1, and it's gonna be then simpler. Yeah, I can have a quick showcase probably. If my workspace is sound. So for example, the automatic start node, which is like the basic thing which everybody needs to take off, has few tests like takeoff should fail because we are outside of the safety area, takeoff should fail because we are missing some topics, takeoff should fail because the drone is moving on its own, takeoff should succeed, takeoff was triggered externally by a service call. So any of these folders will gonna contain a config folder with some custom configs, just like you are used to. There is gonna be the Python launch file, which is gonna fabricate what we need to run. So a MRSAV system with some potential configs, a multi-rotor sim with some custom config, hardware API, and then the test interactor, which is gonna poke into the system. Obviously, there are some more stuff. There is a CMake lists, which we have fabricated in such a way that you don't actually have to modify it between the different tests. So it's basically copy-paste. Then there is some upper CMake lists, which include all of the before, again, some upper CMake list, which is the packages CMake list. And somewhere then there is a section which, if the tests are enabled, they are going to compile and be used. So for this to be enabled in the MRSAV system, you need to compile it with the special mixin for MRS testing. Otherwise, normal people will not have tests compiled because that would be a waste of time. But when they are compiled, you can either run specific tests. There is like a magical command where you insert the name of the test, or you can run all the tests within the package using this magical command. So if I now want to run takeoff should succeed, I'm just gonna takeoff should succeed, insert this here, and hopefully run specific test will like start the simulator, start the core. Obviously no GUI, that's sort of must for the tests, because on the server you are not gonna be able to run GUI. But like locally you could do it if you would want to. Now the takeoff is happening, and the test interactor is somehow poking into the drone and checking if the takeoff succeeded, just like you are used to. And you don't have to have a Tmax session, and in the end you are going to be presented with, this takeoff succeeded, no failures, no errors. So if I'm going to change how it behaves, I'm going to obviously change the configuration. So for the MRS multi-rotor simulator, now I would need to find the right parameter for the real-time factor. So config simulator dynamic real-time factor, yes please, 0.1, and again run specific test. And since the workspace should be built with Stimlink install, I don't need to recompile if I change the config file. Yeah, I'm seeing that the desired RTF is 0.1, so the parameter got through. So now it's gonna take 10 times more seconds. Yeah, totally recommend running tests. Testing the stuff in a Tmax session requires too much of a manual thing, and then you just don't do it as often because it needs you. This doesn't need you. This only needs you to define how the tests look like, and then you have an automated way. And if you are clever, you can sort of parameterize the test. So I have a test for controllers, where each controller is supposed to control or be able to control the drone with certain output modality. The MRS system supports something like 10 output modalities, anything from desired actuators, control groups, attitude tray, and stuff like that. And I have 2 controllers. So I need to do a test matrix for 2 controllers times 9 modalities. And if I program these tests like manually, that would be just too much of a code. So, but this was also possible in ROS1. So you could, for example, specify a test where in CMake lists I have set of controllers, set of modalities, and I have one test which accepts these as an argument, and I just build the test, like I built n times m tests. So for all controllers, for all modalities, I create a test, each has a timeout, and each test accepts these arguments, which are basically the modalities. And each test, which is this Python file, will somewhere parse the modality from the argument. It will parse the controller from the argument. And based on this, it can do different stuff. So for the modality, for example, in my case, I'm loading a different config file because it needs to be somehow changed in a config file. For the controller, I'm passing it as an argument, I think, or maybe not, inside of the test node. No, so I have 2 config files. For each controller, there is 1. And for each modality, there is 1 specific config file. And each test picks up the right config file. But the code that does the testing, the C++ thing, is 1 for all. And it tests if the drone can fly to certain coordinates, some handpicked, 0, 0, 2, and if it can stay there for at least 5 seconds. So the test is typically simple. I recommend to do tests in a very rudimentary way, because the more logic you have here, the more bugs you will create. And then you have a buggy test, which nobody tests. So it's recommended to have the logic in the test as simple as possible, no randomness. Somebody might want, yeah, let's fly to a different location every time. No, that's gonna create non-determinism, and you are gonna be able to like really tune it. So have this as simple as possible. Basically, activate the drone in midair, wait 3 seconds, fly to coordinates, wait 5 seconds, check if the drone is flying. That's the whole test. But you repeat this for all the controllers and all the modalities. So this thing can take easily like 8 minutes, but it does very, very heavy lifting, and it's super, super elegant, I would say. So do stuff like this. Yeah, and testing for these controllers and modalities by hand would be completely like intractable for me. Like, so that's not doable, but doing it automatically is super nice. So please write tests. You are gonna thank yourselves in the future. Yeah. So who has already installed ROS2? Awesome. Awesome. Thank you, guys. That's good. That's good. I need people to start working with it such that we can find the bugs that I haven't found yet early, such that the camp will be a success. Like I'm quite confident about the core. We have flown with it a lot, but anytime you throw 40 more people at it, you are gonna find some problems. So I bet there are gonna be problems, some niche use cases. And as soon as we found about them, that's gonna be better. Yeah. So please help me. It's not gonna be easy, the transition for you. The refactoring itself with the MRS libraries can be sort of mechanical, but still it's a pain. Without MRS libraries, the refactoring would be super painful. Like, don't do it. Yeah. So. Yeah, I hope I haven't forgotten anything. Totally, please check the documentation page on version 2.0. There is a section called prerequisites, ROS2, which has some stuff specific to workspace and installation. And I even tried to fill in some section about like ROS1 to ROS2 patterns, but I didn't actually have like time to do it properly. So this section is somehow empty. Because as I was like rediscovering the stuff, I was always discovering some new things. So the ROS1, ROS2 patterns is not very good, but otherwise we have a good sections about the Dockerized deployment. We have a quite good section about sensors. So I want to run Oster. How I do it? I want to run Luxonis camera, Blue Fox, WheelSense, LiDAR. Like there are manuals about how to run these sensors. So please definitely check it. There are, the simulation section should be up to date. So how to run Gazebo should be up to date. How to run MRS should be up to date. How to run FlightForce should be up to date. Even though these banners say it's probably not up to date, some of these are. So definitely, please check this. If you find a discrepancy, fix it yourself if you can. Please help. Like if I had all the time, I would definitely go through this mechanically and update it myself. But this is like the features were priority over documentation, definitely. And the features are still lacking, so it's still a priority. So use the docs. Don't forget to switch to ROS2 branches everywhere you go on GitHub. Check the examples. The core examples should be your main source of inspiration, as well as any package within the MRS UAV core. So the auto start, control manager, UAV manager, these are the places where I am going when I'm stealing my own code for other packages. Yeah. So that's it from me. If you don't have any more questions, thank you for coming. I'm not sure if we are going to see each other at the camp. I might be in the nursery in that time. If I can come, I will come for a few days. Anyway, contact Philip if you have any questions, and he's gonna either forward it to me or somehow manage it himself. So thank you. See ya.